This picture is of Louise Brown, and some of you may know this story. So this is our first baby that was born as a result of in vitro fertilization. And what that means is they took the egg from Louise's mother, some sperm from Louise's father, and they mixed it together in a dish, so outside of the parents. And then they were able to create little embryos and then implant one of those embryos back in the mother. She carried the baby to term. So we're all aware of in vitro fertilization, but back in 1978, this was huge, huge news, and the fact that her name is still known says a lot. Okay, then we're looking at this guy who also won a Nobel Prize. His name is Sir Martin Evans, and another fellow derived stem cell lines from mouse embryos. So they had little mice, embryos, like this picture, and they were able to take some cells out of there and have those grow in a dish for a very long time. And these cells could divide and make more of themselves. They're sort of nondescript, but then they could change and become all different types of cells. So this was important, and this was just 1981. So we're only looking 30 years ago, not even. Another slide of history. This guy, his name's Irving Weissman, and he found stems. He really was able to more completely identify the stem cell that's in bone marrow that helps when we do a bone marrow transplant. So he was able to give us more information about that. This is hard to see, but that's we started in 1990 the Human Genome Mapping Project, so we knew what recipes were in each chapter of the book. So if you want to look at it that way. So here we have, does anybody know this sheep's name? This is our first mammal that was cloned. Anybody remember? Dolly, very good. So this was Dolly the sheep, cloned in Scotland. This guy is Jim Thompson. He is not the illustrious former governor of our state, as you can see. So he is from the University of Wisconsin, and he isolated the very first human embryonic stem cells. And I can only imagine his life is very, very interesting, but also probably quite difficult, because he's probably endured a lot of attacks for having done this. So he was able, so we had Sir Walter Evans isolating from mice, but he was able then later to come along and isolate human embryonic stem cells from in vitro fertilized embryos. So that's why Louise Brown was important. Here's George Bush, and he basically announced the U.S. embryonic stem policy, and he said, okay, we cannot create any more human embryonic stem cells. We will not touch any more human embryos to make stem cells. You can only use the ones we already have. All right, so that's what he said in 2001. Well, you know, some scientists were like, but wait, how are we going to continue? There are a lot of good reasons why we should have more, but getting this sort of constraint on their life, scientists had to think differently and go, well, now what do we do? People are upset about using embryos. We got to do something different, which I'll get to in a minute. In 2001, we also figured out how to take these human embryonic stem cells, that's what HESC stands for, human embryonic stem cells, and then make them change into muscle, and make them change into neurons, and make them change into pancreas cells that secrete insulin. Okay. Then we have this fellow. He supposedly made a first cloned human being. And this guy in Korea, so he supposedly did this, so he's very happy because this is a big breakthrough, and people were really excited about this. But then he was discredited, so now he's really upset. But because there were just some ethical issues behind the way he worked on this. Okay, so we are almost done. Last slide. So here we have some neural stem cells repair mouse spinal cords. There is this, and rat spinal cords too. There's a famous video out on the web of these rats where they were injected. They had a spinal cord injury. They were injected with neural stem cells, and then there was a bit of repair, and the rats were able to walk again. So maybe you've seen that video. I know I've seen it many, many times. So this was a big thing. This is the world's first cloned dog, Snuppy. So down there we will talk about what cloning is and how it's done. So we've got this dog that's an exact copy of its mother, right? And that was done by the Korean fellow who was disgraced. So he's still able to work, he just can't work with humans anymore. Okay. Here we have California with Arnold Schwarzenegger. They really pushed through this Institute for Regenerative Medicine, so the Stem Cell Initiative. So there's money for stem cell research in California. Here, this was a big break. This was the thing where scientists said, well, we are not allowed to do this, so what can we do? So what they basically decided to do was to figure out how can we create a stem cell that's like an embryonic stem cell without destroying embryos. And we'll talk about how that's done. In 2007, the first Nobel Prize for embryonic stem cell research is awarded. And then in 2007, we were able to clone a primate, sort of like Dolly, but now we're able to do a monkey. And then these are skin cells. So just like this research with the Japanese and American scientists creating mice embryos without, or embryonic stem cells without embryos, we were able to do the same thing with humans.